This is First Coast Math Clinic with lesson 4, the distance formula from Unit 11 triangles from our Pre-Algebra and Algebra curriculum. So the goal in this video is to use the distance formula to find the length of segments on the coordinate plane. And I want to start by just explaining what the distance formula is and relating it back to the Pythagorean theorem from lesson 3. So if you're not interested in that, if you want to just get into some examples, you can jump ahead to the first couple examples. But I'm going to start by going through the Pythagorean theorem and relate it to the distance formula and show you where the distance formula comes from. So let's say we've got a right triangle here on our coordinate plane. We know that from lesson 3, the parts of this right triangle, we've got the hypotenuse, a leg, and a leg. And we know that our Pythagorean theorem says the hypotenuse squared is equal to leg squared plus the leg squared. All right, but I want to denote the hypotenuse, leg, and leg a little bit different, right? So using our distance formula, we're going to be finding this diagonal length here. So instead of calling it the hypotenuse, we're just going to use the letter D to represent the distance, right? So I can replace hypotenuse with D. So that's going to be D squared. And I want a way to tell apart our legs. So this is going to be leg 1 right here. So we have leg 1 squared. And this is going to be leg 2. So leg 2 squared. So just color coding this a little bit. So this is going to be our leg 1. And this is going to be just a different color there. This is going to be our leg 2. Okay. So let's figure out what I want to do is figure out, well, how can we find the length of leg 1 and leg 2? So let's do that now. And let's represent these points here and here using our coordinates. So I'm going to use x1, y1, x2, y2. So if I want to find the length of leg 1, well, leg 1 is a horizontal distance, right? So how could I find the length of this leg 1, right? Well, what coordinate is changing? If it's a horizontal length, the x values are changing. So to find the length of this leg, I'm going to take x2 and subtract x1, right? Because if we think about it, the length of this leg is 1, 2, 3, 4. I can get that by subtracting my 7 here minus my 3. So 7 minus 3 equals 4. So that's my length of leg 1. So we're going to use this expression for leg 1. For leg 2, we'll use x2, y2 again. Well, now, what coordinate is changing? We've got a vertical line here. And what's the length of this line? This line is 1, 2, 3. Since it's a vertical line, it's going to be the change in our y coordinates. So this is going to be y2 minus y1. And if we want to check that, well, what's our y value here? The y value here for y2 is 5. y1 here is 2. If we do 5 minus 2, we're going to get 3. So we're going to use this expression for leg 2. So I'm going to substitute x2 minus x1 in for leg 1, y2 minus y1 in for leg 2. So let's rewrite this. So I'm going to get d squared, which was my hypotenuse, or is my hypotenuse, is equal to x2 minus x1 squared plus y2 minus y1. Let me get rid of this. Squared. So we've got our formula with x1, y1, x2, y2. We either get d by itself. I'm squaring d. How do we undo squaring? We could take the square root. and square root of both sides. So that gives me my formula. It gets my d by itself. So we're going to get d is equal to, our distance is equal to x2 minus x1 squared plus y2 minus y1 squared. So that gives us our distance formula. Okay. I wrote it a little bit backwards, just to put the y coordinates separate or second. So my y coordinates are here. X coordinates are here, but it's the same thing. Okay. So what I'm doing here is just trying to show you guys that all this is, the x2 minus x1 is just the length of that horizontal leg on the right triangle. The y2 minus y1 is just the length of the vertical leg on the right triangle. Okay, so that's where our distance formula comes from. Now let's use this distance formula to find the distance along the hypotenuse, that length d. So for number one, we want to find the distance between points A and B and use the distance formula to do that. Point A is -2, 4. Point B is 6, -2. So let's plot point A at -2, 4. Let's plot point B at 6, -2. So our value D is going to be the distance between these 2 points. So what I like to do is start by just identifying our values for x1, y1, x2, y2. And I like to go from left to right. So my leftmost point, that's going to be my x1, y1. My rightmost point, that's going to be my x2, y2. So this will be -2, 4, 6, -2. So we can substitute those values into our formula. So x1 is -2, y1 is 4, x2 is 6, and y2 is going to be -2. And the biggest mistake, or one of the bigger mistakes students make when they use the distance formula, is substituting values incorrectly. Since we're squaring, the sign inside the parentheses doesn't matter if you get a negative or a positive. When you square, it's going to wind up being positive anyway. But we have to make sure that we're substituting our y values in for the y values, our x values in for the x values. So let's do our substitution. So it should be -2 minus 4 squared plus 6 minus -2 squared. Second big mistake, or another big mistake, is kind of order of operations. When we're simplifying this, we want to simplify inside the parentheses, then exponents. So let's do our operations inside the parentheses and inside the parentheses. -2 minus 4 is going to give us -6. So get -6 squared plus 6 minus -2. We can rewrite this using our addition or subtraction rule. So it's going to become plus positive, and we're going to get 8 squared. Now we can square -6 squared, 8 squared. -6 squared is 36. 8 squared is 64. Let's add them up. We get 100. And the square root of 100 is going to be +10 and -10. We know that from our lesson 2, we're going to get 2 answers, a positive and a negative, when we take the square root. But we're looking for a distance. Since we're looking for a distance, a physical measure, we're going to discard that negative answer and just keep the positive answer. So our answer is going to be +10. Okay. Now, something else I want to point out to you guys, relating this back to the previous slide, my explanation of where the distance formula comes from. All right, if I were to we kind of draw in the vertical and draw in the horizontal. Well, look what we get here. We got a right triangle, right? What are the distances? What's the length of the vertical and the horizontal, the sides, legs of this right triangle here, right? This leg is 8, which is that value. This leg is 6, which is that value. Okay. So again, what I'm trying to show you guys is the change in y and the change in x are basically just the distance along the sides of the right triangle that are created from that diagonal. All right. Let's get to a couple more examples where we use the distance formula to find the distance between 2 points on the coordinate plane. Okay, so for number 2, we've got A is 2, 4 and B is 10, 14. So let's start by plotting our points. So A at 2, 4 and B at 10, 14. So we're going to go off the grid a little bit. So 10, 14, we're right about here. So we're looking for D, which is the distance between A and B. It's 10, 14. And that's 2, 4. So let's label our coordinates. We want x1, y1. So that's going to be 2 and 4. And then x2, y2. That's going to be 10 and 14. So let's substitute our values into our distance formula. So x2, or excuse me, y2 is 14 minus y1, which is 4 squared, plus x2, which is 10, minus x1, which is 2. Let's simplify this. 14 minus 4 is 10 squared, plus 10 minus 2 is 8 squared. 10 squared is 100. 8 squared is 64. And then we get 100 plus 64 is 164. So 164 isn't a perfect square. So what we can do is let's break this up into maybe square root of 4 times square root of 41. So 4 is the largest perfect square that goes into 164. Square root of 4 is going to be 2. So we're just going to keep the positive square root. So square root of 4 is going to be 2, or positive root. And then we'll keep square root of 41. We're just going to keep the square root of 41. So our distance is going to be 2 square root of 41. So this is our exact. And if we want the approximate, we plug this into our calculator, we should get about 12.8 as our approximate value. Okay. Now, again, just kind of going back to what we've been doing in the previous couple examples. If I draw in the right triangle here, right, our vertical distance is going to be 14 minus 4. So this is going to be 10. Horizontal distance is going to be 10 minus 2. So that's going to be 8. And where do we see these values? Well, we've got 10 here, and we've got 8 here. So again, these values that are getting in the parentheses here and here are just the horizontal and vertical distance on the right triangle that we're forming, that we can create by plotting our points for A and B. All right, let's get into a couple more examples. So A is negative 1, 3, B is negative 4, 9. Again, we want to use the distance formula to find the distance between these 2 points. So let's sketch this out so we can see what this looks like. Both these points are negative positive, so they're both going to be in quadrant 2. So negative 1, 3 is going to be kind of over here. So that's point A at negative 1, 3. B is negative 4, 9. So again, I'm going to go left to right. x1, y1 is negative 4, 9. x2, y2 is negative 1, 3. So let's substitute our values in. x1 is negative 4. y1 is 9. x2 is negative 1. And y2 is going to be 3. So in our parentheses, we're going to get 3 minus 9 squared plus the difference in our x coordinates, x2, negative 1 minus negative 4 squared. 3 minus 9 is going to give us negative 6 squared plus, use our subtraction rule, keep, change, so it becomes plus positive, and we're going to get 3 here, so 3 squared. So now let's pause here for a second, and I'm going to draw in the remainder of this triangle. So let's look at this, right? So our vertical distance, right, is going to be the difference in our y coordinates. Well, 9 to 3, what's that difference? The difference is going to be 6. Well, we got 6 right here. The horizontal distance, well, that's going to be the difference between negative 4 and negative 1. Well, that is 3. We got 3 right here, right? So again, these values are just the vertical and horizontal distances on the right triangle that's created from the 2 points that we're trying to find the distance between, okay? So let's keep going here. And again, even though this value here is negative, we're squaring it, so it's just going to become positive anyway. So we get 36 plus 9, and our distance equals the square root of 45. So let's find our exact square root and our approximate square root. So our exact square root, we could break this up into the square root of 9 times square root of 5. Square root of 9, we're going to keep the positive 3 times square root of 5. We can't break up that 5 any further, so our distance is going to be 3 square roots of 5. So this is exact, approximate. If we plug this into our calculator, we're going to get 6.7. Okay. All right, let's get into a couple more examples. All right, so let's do one more example. We've got A is negative 4, 7. B is 5, negative 3. So we've got negative, positive, negative. So our coordinates are going to be, A is going to be in quadrant 2. So negative 4, 7 is going to be right here. And then 5, negative 3 is going to be in quadrant 4. So B, 5, negative 3 is going to be right here. So we want to find the distance between A and B. So let's identify our x1, y1, x2, y2 to start. So I like going left to right. So negative 4, 7, 5, negative 3. So x1 is negative 4, y1 is 7, x2 is 5, and y2 is negative 3. So let's do our substitution. So we get D equals the square root, negative 3 minus 7 squared plus 5 minus negative 4 squared. All right, order of operations. Let's simplify inside of our parentheses first. 3 minus negative 7, this is going to give us negative 10 squared plus, to use our subtraction rule here, 5 minus negative 4 becomes plus positive, so we get 9 squared. Before I keep going, let's draw in our triangle. All right, to find our height, right, our change in y. Well, what's the difference in our y values? Difference between 7 and negative 3 is going to be 10. All right, so that is this value. And again, the negative doesn't matter because when we square it, it's going to become positive anyway. And our x value is going to be the difference between negative 4 and 5. So that difference is 9, which is this value right here. All right, so let's simplify this. Negative 10 squared is 100, plus 9 squared is 81. So we get the square root of 181. Now, when I simplify this, I like to try and find the exact and the approximate answer, but there's no real perfect square that I can break up the 181 into, so I'm just going to plug this into my calculator, and if I round this to the nearest tenth, we should get 13.5 as our approximate answer. All right, so our approximate answer here is going to be 13.5 for our distance. Okay. All right, so this was lesson 4, the distance formula from Unit 11, triangles. If you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.